Let's take a look at example 2. I want to ask the same question, determine the open intervals on which this function f of x is concave up or concave down. It's another question with regarding concavity, so we know that we want to use the second derivative. We would begin by finding the first derivative. We want to find f prime of x. That would require the use of the quotient rule on this one, because we have a quotient. I'm not going to show all of the algebra involved in this, but if you perform the quotient rule, the simplified version for f prime of x should work out to be negative 10x divided by x squared minus 4 squared. So that's the first derivative via the quotient rule. We would now want to go ahead and find the second derivative. Again, I'm going to skip the algebra for this, but you would once again want to use the quotient rule. If you use the quotient rule again and simplify it all the way, you would find that f double prime of x would be equal to 10 times 3x squared plus 4 divided by x squared minus 4 cubed. Now that we have our second derivative, we want to do a sign chart for this. The values we're going to put on the sign chart are going to be the values where f double prime is equal to 0, and also the places where f double prime would be undefined. Let's first solve for where f double prime of x is equal to 0. We set 10 times 3x squared plus 4 all over x squared minus 4 cubed equal to 0. We have a fraction equal to 0. You'd want to clear the fractions, multiply both sides by the denominator. We would get 10 times 3x squared plus 4 equals to 0. We could divide by 10. We have a quadratic without an x to the first power term, so we can isolate the x squared. You would subtract 4 and then divide by 3, and we would get that x squared equals negative 4 divided by 3, which would produce complex solutions. Again, we're only interested right now in real valued solutions, so there are no real values where f double prime of x would be equal to 0. We do, however, have some places where f double prime of x is going to be undefined. If we set the denominator of f double prime equal to 0, that is where x squared minus 4 to the third power equals to 0. To solve this equation, we can get rid of the cube power by doing the cube root to both sides. The cube root and the cube cancel. We get x squared minus 4 equals to 0. Add 4 to both sides and take the square root, and we get two values, x equals positive and negative 2. Let's place these numbers on a number line, and we're going to do our sign chart for f double prime. Here's negative 2, here's positive 2. Those two values break up the number line into 1, 2, 3 different regions. Let's do a test point for region 1. Let's say maybe x equals to negative 3. F double prime of negative 3, that's going to be equal to 10 times 3 times negative 3 squared plus 4, all divided by negative 3 squared minus 4 cubed. Let's see if we can work this out. In the numerator, negative 3 squared would be 9. 3 times 9 is 27. 27 plus 4 is 31. Times 10 would be 310. In the denominator, negative 3 squared is positive 9. Minus 4 would be 5. And 5 cubed is 125. Irregardless, that value is going to end up being positive, which means that f double prime in the first region is positive, which means that the graph is going to be concave up there. So in region 1, the graph is concave up. let's pick a test point for region 2. 0 is always nice when you're able to use it. If we want the value for f double prime of 0, this is going to be 10 times 3 times 0 squared plus 4 divided by 0 squared minus 4 cubed. If we work this out in the numerator, we're going to have 0 squared is 0, times 3 is 0. So we're going to have 4 times 10, which is 40. In the denominator, 0 squared is 0, minus 4 would be negative 4, and the negative 4 cubed would be negative 64. So we're going to end up getting an answer that's negative, which means that in region 2, f double prime is less than 0, which means that the graph is going to be concave down there. So the graph should be concave down. Let's take a look at region 3. A good test point here might be to use x equals to 3. Let's plug 3 into the second derivative. F double prime of 3 excuse me. Is going to give us, let's see, 3 squared up top, that's 9, 27 plus 4 is 31. So we get that 310, and that will once again be over 5 cubed, which is 125. So f double prime will be positive in quadrant 3, not quadrant 3, but region 3, which means there that the graph will be concave up. So to summarize, we now know the concavity of this graph. F of x is concave up from negative infinity to negative 2, and also from 2 to infinity, and this graph would be concave down between negative 2 to 2.